Bismillahirrahmanirrahim. Greetings. In this video lecture and a few more to follow, I intend to discuss the mathematical concept of function. Now, I will be presenting my lectures at a mathematical curriculum of, let's say, pre-calculus. That includes, of course, college algebra and basic algebra. Now, students taking the first course in calculus, they also will benefit from them. In order to motivate and enhance your conceptual understanding of the subject, I will be using a schematic diagram and graphs, and also for analytical purpose I will be using algebraic equations. Now, there will be some terms that I will be using in this video that I have not formally defined, and I will be postponing the definition of them. If there is a need for mathematical, rigorous mathematical definition, I will go over them for the following video lectures. I strongly recommend you to watch all the videos. That will be about 3-4 of them, possibly not too long each of them. And once and for all, you overcome the difficulty that you may have with function. Now, the subject of function starts from grade school. It's not something that you hear in college. From the time that you start to add and subtract, you are dealing with function. Those are binary function. They have input and they have output. We will go over all of them. And now, the one thing I would like to share with you is that I fall down with my bicycle and I have broken few teeth. So my voice is a little bit unusual to myself even. I feel very uncomfortable. And hopefully someday soon, I don't know how long it takes, I may have implants and give a better lecture for that. Okay then, let's start, shall we? Function is a rule of correspondence between two non-empty sets. Let's call them A and B. Such that each member or each element from first set, we called it A, is paired with what? With at least one element from the second set. Now, I don't have to write it because I did speak slowly, and also you have upper hand that you can pause and write if you like to write what I just mentioned it. Now, in this definition that I made, by the way, every definition must be an if and only if statement. Now, this definition that I made about function pass that requirement. That, of course, in other videos I will go over them for you. Now, the other thing is that in this definition, the rule of correspondence, each and at least one play a very important role in order to fully comprehend the concept of function in this case. Now, rule of correspondence, as the name says it all, is the rule that says what element from the set A should be paired with what element from the set B. So we call it rule of correspondence. Now, the word each is very important. For instance, when I said to the class, each of you should give me $1 before you leave, that means all of you, each and all of you should give that $1. So each indicates that all the elements from the first set that we called it A should be used. Of course, later on, that set will have a name. We call it domain, and we say that function eats every element in its domain. So there should not be any element left in the domain, otherwise it's not a function. Are you with me? Okay, then let's go through a schematic diagram, and also I have put them. I will do mechanically zoom in and out so that I stay also out of way to explain the situation for you. So let me go and zoom this one. So here, I stay out of your way. Here, this is a schematic diagram. As you can see, each element, not each element, there are 3 elements in this case, they all have paired with some element in the set B. But there is one element left. There is one element left in the set A that has not been paired with any element in the set B. So as far as a schematic diagram is concerned, this does not represent a function. All right? Now, since function must eat all the elements in its domain that I'm a little ahead of the time, I'm kind of waving my hand, assuming that you are familiar with these words. I will go over them more precisely in other videos. Here, this is not even a relation to begin with, because this element has not have any pair with that. So this is not a function to begin with. And one example I can make maybe is this one. Now here, if we take if we define y to be from interval from A to B, union with C to B, D, these 2 intervals, then this perfectly defines a function. But if we say the interval is A, our interval, we call it A, is from A to D, which includes the interval that here I haven't put anything like B and C, includes that interval, then this graph is not the graph of a function. Again, so many elements here that they have not paired with anything up or down. So this is not the graph of a function. All right, now let's go to the next one. Okay, in this case, I have a schematic diagram that, as you can see, the elements in the set A, all of them have been used. So he passed the first condition, all of them have been used. And each of them, in this case, they have been paired with 2 elements in B. You see that our schematic diagram shows this perfectly. So I call this one 1 to 2, 1 to 2. One of them is paired with 2 elements in B. Now, the graphical representation of that is a circle that you have seen it in high school, in junior and senior high school, also in college. And this is a nice looking, satisfies our definition. As you can see here, the A, I hope is visible to you, is paired with B, and A is also paired with minus B. So 2 elements A is paired with. And same is true here, as you can see. I have written the algebraic formula for that. And here again, A is paired with B and minus B. Now, this, students immediately may raise their hand and say, hey, I have seen in high school that they say vertical line must hit the graph in only 1 point. But here vertical line is hitting in 2 points, in fact, most of them, and this is true here. So how come you're using the word function for that? Now the answer is that The vertical line that you are talking about, first of all, is that is acceptable for a 1D or 2D or at most 3D geometry. But when we go to more than 3D, we can no longer use so-called a vertical line. Vertical line is for junior high school, for the beginning, to explain to them. But what if you don't have the graph? Number one. And number two here, when I say A is paired with B and minus B, the B and minus B are not selected randomly. There is a rule, there is a corresponding rule that determines B and minus B and nothing else for the what? For the number A in the horizontal axis, in the x-axis. So I call this one 1 to 2 function. 1 to 2. 1 to 2. Are you with me? Okay, now let's go to another one, if I may. Now here, my set A contains only one element in a sense. And this element is paired with so many other ones, as you can see. So this perfectly satisfies the definition that I mentioned, that each element in the set A is paired with at least one element in the set of B. So I call this one 1 to many. 1 to many. An example for that could be a vertical line. Now here is A, and A is paired with y1, that's y2, y3, and negative y1, negative y2, negative y3, and so on and so forth. And also, in order to say that A here is not a point on the number line only, but represents a line, a vertical line, so it's better to write it in set notation and set the set of all x and y such that x equals to A. This represents what? Represents this vertical line. So you know you are not talking about a single point on the number line. And also, since it is to the level of curriculum of calculus, also a beginning calculus or trigonometry, which is in pre-calculus, you are familiar with the graph of sine, and then the inverse of sine, that I will be going into that much more detail in videos to come. This is the graph of inverse sine. As you can see here, A is paired with this point, this point, this point. I don't use the word or, but it's an and. So this A is paired with this, and this, and this, and this, and this, and as you can see, a vertical line will hit this graph in infinitely many points. So this definitely perfectly satisfies the definition that we made about function. Now, so hopefully you are familiar, you are comfortable with this. Huh? So now let me zoom the video so that I could go over them by talking. Okay, the students, they say that, you know, the schematic diagram that I draw, they say this is not mathematics. This is just like dropping, what is it, an arrow or something, dart, excuse me. Now, the matter of fact is that when we go to function and this inverse, we will see that the schematic diagram, if a function is 1 to 1, on to, into, that we will be seeing it soon in other videos, the schematic diagram gives us enhance our comprehension and conceptually understanding the subject. 1, 2, and adding, subtraction, multiplication, division belongs to grade school. So when we go upper level courses, then even in especially abstract algebra, the subject of the test of the set that we deal with are even no longer numbers. So we are dealing with objects that they are not numbers. But the algebraic operation that we are familiar with is applied to them. So you have to kind of expand your horizon in a sense, and do not shy away when you see the schematic diagram, because it enhances your conceptual comprehension and understanding of the subject. To think and reflect, critical thinking and analytical thinking, very important. That's what all mathematics is all about. Alright then, I hope that this short video was beneficial to you, and when we go to other videos, then I will be talking about function as a single value function. So the definition remains same, only the one that it says each element in the set is paired with at least one. The word at least will be replaced with uniquely, is paired uniquely with that element in B. So the uniqueness will replace what? The at least one. But this one that I just mentioned now is called multi-valued function. Not multi-variable, but multi-valued function. And in calculus you will be hearing that word, and there are many textbooks that also use that. So it's not that you say vertical line fails, so you cannot call it function. Again, you can call it function. Why? Because the elements that are paired with the elements in the set A, they are paired with certain discipline. The elements in the set B are not selected randomly. That is the reason the word function is applied. But we call it multi-valued function. But traditionally, and also for the subject before calculus, freshman, like college algebra, basic algebra, pre-calculus, they do define function for a single valued function. And if it is not single valued, like the graph of a circle, they call that one a relation, not a function. But relation itself has a definition and property that in the following videos I will be covering. Okay then, I thank you for watching. For the second time, I strongly encourage you to watch the rest of the other videos, and hopefully they will be very beneficial to you. Okay, I give you all an army salute and wish you all prosperity, and please stay safe. So long.